on, but where is it? Oh man. Okay, it's live. Why is the thumbnail always the wrong thing? I gotta find it again. There it is. Let's go with that. Okay. So I haven't done a stream in a while. So I decided to do something to go over like the upcoming Ryzen 7000. So AMD had a big announcement on Monday going over the launch for Ryzen 7000 series. Now, the main thing though is they didn't really go into too much detail on the chipset, the motherboards, and that sort of thing. So that's kind of what we're going to cover in this stream today. So for those tuning in, so this channel is all about technology stuff. We cover gaming. I haven't really been active, to be honest. I really need to put more content out there. But for the most part, this is gonna be more of like an educational stream for those that are interested in getting into either PC gaming, or I guess this is a little bit more suited for those who are looking to do content creation, because I think that content creation is going to be a big topic here. Primarily because there is a lack of HEDT. There's not a lot of HEDT options now that are modern. So typically, the way I see it is, here, let me go ahead and share application here. Let me see, how do I want to do this? It's window. So if I do that, now it shows the capture card. What happens if I want to show, let's say, paint? Okay, that works. So let's share paint, and we maximize that out. Oh boy, now people can't see me. I gotta move this down. Okay, so let's go over like what this entails for those that are curious. So actually, I don't need this window anymore. There. Okay. So okay, you have, I guess what we're going to address is we're going to go over Ryzen 7000 CPUs. That is Zen 4. That's the CPU generation. It is also the AM5 socket, or we'll just say socket AM5, socket LGA AM5, or AM5 LGA. It's a land grid array. I think a lot of people already know this. So this is more like normies type of info. Like, I think typically everybody knows this already. The chipset that we're going to be talking about today specifically is going to be X670e. There is also, here, we'll just go ahead and make this plural. There's also X670, which this is actually a derivative of. And then there is B650, which is actually what the chipset really is in its base configuration. So that is to say that X670e is nothing more than it's basically two B650 chipsets stacked together in a primary secondary configuration. So what do I mean by that? Typically what that means is that you have the CPU up here, we'll call this CPU, and then down here you have a chipset, we'll call this X670e. But this is actually two things. This is actually two chipsets. It's actually a dual chipset. So rather than it being, here, let's just make this easy for people to see. So it's actually two chipsets together, and the total, or I guess both of them together is actually X670e, or X670 in this case. So it's actually a dual. The chipset is actually a dual chip configuration. That's actually what it is. So it's actually two. So you're actually getting two for the price of one, I guess. There was an article, I think Tech Power Up covered it, that something about the pricing. Like, they were able to like, the price of like 21 of these B650 chips are, you know, essentially the cost of a single X570, which is the last generation. So you have, this is actually B650, and then B650. So you actually have like two B650s, and the two of them together is basically what we call X670. What's the difference between X670e and X670 non-E? The main difference is going to be your Gen 5. So PCIe Gen 5 is the primary difference. So PCIe Gen 5 with X670e is going to be on both the PCIe X16 slots and the M.2. One M.2 will have an X4 configuration. Whereas if we're talking about the non-E, that one, the PCIe Gen 5 goes to the M.2. So it's probably going to come with like two M.2s for a X8, and I'm not sure. It'll be up to the manufacturer, like motherboard manufacturers' discretion on how they want to divvy that up. Like how they want to actually divide that. So the way this works is the CPU has lanes, right? It has lanes, and it goes to the chipset, and then the chipset, in this case we're talking X670e, so there's actually two of them. So you have kind of a hierarchy here where you have a primary one and a secondary one. My guess is that the primary one is responsible for your storage lanes, your PCI lanes that are meant for storage, and then I think the secondary one is probably going to be things like, you know, audio, networking, SATA, USB, that kind of thing. I could be wrong, could be the other way around, I have no idea. I don't know that much about it at this point, but that's basically how it's set up. So now if we want to go over, let's go over, this is going to mess up how this is sharing. Here, let me go here, and we will just hide, where's paint? We'll just hide paint for now. Okay, so the chipset is available. We're going to talk about X670e. That's the primary topic of this discussion here, but we will talk about a little bit more stuff like DDR5 and how to prepare and what do you do. Because, so in the live stream, or in the reveal, or the unveiling, Lisa Su said that they don't expect to have shortage problems with the launch. So, and in my experience with the Ryzen 5000 series, so I mean, I got my 5800X still right here. You guys can see that. That's what I'm running right now. That's what we're streaming on. So it's an awesome CPU. Never really had any problems with it. It's low power, high performance, etc. At launch, I think the only model that was hard to find in terms of the CPUs was the 5950X. All the other ones were easy to get. I think the 5900X sold out initially, and maybe if you were at like a launch event at a Micro Center or something, you had a hard time getting one. But for the most part, they're pretty easy to get. Like I don't think it's gonna be a problem. The main problem is going to be getting the motherboards and the DDR5 that you want. That's what I think is going to be the bottleneck here. Because that, essentially, when you think about it, like the reason why graphics cards were hard to get is because you're buying the full board with the cooling, the memory, and the GPU chip itself. So that's kind of like buying, you know, the full system. It's like a full system, essentially, as a GPU. Whereas here, you're having to buy things separately. So you're having to buy the CPU, the memory, and the board. All three of those things are sold separately. So finding the one you want is going to be just as hard as getting a GPU at launch, or a particular model. So in this case, we're going to be covering the main flagship models today. So we're going to be going over these different ones. We're going to look at which one would be the smart buy, which one is the overspenders buy, which one is the budget conscious, but they still want X670e, and so forth. Now, I don't know how much any of these cost. I'm not privy to any of that info at this point, but what I do know is that, in my mind, Asus typically has the best UEFI to navigate through, but I do think that Asus, unfortunately, has kind of priced themselves out of the market, at least when it comes to looking at Intel's 12th gen Alder Lake last year, as well as the 11th gen, back in May of 2021, and Asus really started to ramp up the price back when, AMD launched the Ryzen 5000 series. I feel like Asus, unfortunately, kind of priced themselves out of the market. Like, I think they have a lot of SKUs. They have the Pro Art, they have the Prime, the Republic of Gamers stuff with the Crosshair series, of course. But I do think that they're kind of, I want to say they've kind of priced themselves out of the typical buyer's market. Like, I think if someone's looking at getting the top tier chipset, so in this case X670e, are they really going to consider Asus unless they're a real diehard fan of ROG, or unless there's somebody who has always bought ROG and they've had a good experience with them. They never experienced like an RMA situation. They never had to deal with support, for instance. Then I think they're probably going to stick with Asus regardless of how much it costs. But I think that the Extreme, which I think is the one that most people would be best off with, because I think that they're kind of skimping on a lot of the functionality on their lower end ROG SKUs, like for example the Gene, the Hero, the fact that there's no formula anymore. You used to get a lot more for your money with Crosshair in the past. The best example I can think of, now I know this is going way back, but 10 years ago, the Crosshair 5 formula and then the Formula Z for the Vishera 8350, like those things were really, really good for the money. I think that motherboard was like $240 back in 2012 for the Republic of Gamers Crosshair 5 Formula Z, that typically you'd pair up with an FX 8350 if you wanted to play like Guild Wars 2 or that sort of thing. That was kind of the way to go if you were on AMD all those years ago. But over time, they came back with the Crosshair 6 with X370, and that was a really nice board. It was probably the best board if you wanted to run 3200 megahertz on the RAM. That's what I was running. I mean, I did a couple of live streams with overclocking covering that board back in the day, back in the initial Ryzen Gen 1. But actually, let's go ahead and get into it. Let's look at Asus as we're talking about it. So let's look at their website here. So this is the Extreme. So this is the one that we have the most info available on right now. Let me go ahead and make this a little bit bigger so people can see. I don't know how well that shows up on stream. So yeah. So let's look at the just the listing here. So you get the dual B650 chips. So those two together become X670. This is X670e, so that means that you're going to have Gen 5 on your X16 slot, so it's going to be the top one up here, as well as the secondary X16. I think so the way it's going to work is if you want to plug in two graphics cards, for example, if you wanted to do Crossfire, or if you wanted to do, more realistically, you wouldn't do dual GPU anymore, but what I can see a lot of people doing is they're either going to want to plug in a capture card, or they're going to want to plug in like a PCI expansion card to run like a RAID 0 M.2 setup, whether we're talking like a 4x4, so a bifurcated X4. I can see a lot of people doing that, and they put the add-in card in the secondary slot down here. The only problem with a lot of those cards is they prevent you from using the third PCIe slot down there, so that X4, for someone who's live streams, like a hardcore live streamer who covers games on release day, or a variety streamer who would stream console and PC, like typically the by 4 at the bottom is where you're going to put in your Elgato capture card or your AverMedia like Live Gamer 4K or something like that. I mean, that's what I do personally. So I'm just speaking from personal experience here. I mean, that's how I would use this board. So The nice thing about this board is they do give you the they call it it used to be called the DIMM.2, which is essentially a vertical mounted PCIe or an M.2 card or add-in card. They've renamed it in this generation. They call it the ROG Gen Z.2 card. I don't know why they're calling it Gen Z. That's a really odd choice of wording there. But anyway, essentially you get Gen 5 M.2 slots on there, which I think you can do. There's two, one on the front, one on the back. I think that's how it works. I forget exactly. Maybe there's a picture of it here. But if I was going to be buying Asus, I would not consider the Extreme. I think it's probably going to be really expensive. People are going to want to know in the chat, like, how much does this cost? If you're watching right now, you're just tuning in, and you're just wondering, like, what we're talking about, go ahead and comment. How much do you think the X670, or actually, maybe I should do a poll, although there's not enough viewers for me to do a poll, so we're not going to do that. But I would say, if I had to guess, this board is probably going to be $699, somewhere around there, I would guess. Maybe $599. I don't think it'll be $1,000 or anything ridiculous like that. If it was that much, they probably only manufacture like maybe a couple hundred of these, I guess, because I don't think it'll be a bestseller. It's got way too much like RGB for those that are into that, but I feel like if we're talking like building an HEDT equivalent using consumer desktop, mainly because unfortunately there is no real HEDT platform today. I mean, obviously there's Threadripper Pro, but Threadripper Pro is not considered HEDT. That's classified as a workstation board. So I guess that leads me into going over what the hierarchy is here. So let's go back to Paint real quick. I want to cover that so that people who are tuning in understand the hierarchy when we're talking about computers. So whoops, that's not what I wanted to do. So computer, I can't even spell hierarchy. Computer tier list. We'll just say that. We'll just make it easy, right? So the S tier, is basically enterprise. Well, okay, we'll just say servers. We'll just make it easy because some people won't really understand what the difference between enterprise and servers are. But essentially, there's servers. Then you have A tier, which is workstations. And then you have B tier, HEDT. HEDT, for those that don't know what that means high-end desktop. So think something like Threadripper, like old school Threadripper would be HEDT. And then C tier is mainstream desktop. And I guess like D tier would be laptops. E tier would be like mobile like tablets or something. I guess we'll just say tablets. So in general, the lower the amount of electricity consumption, the lower it is on the tier list. That's an oversimplification, because obviously things aren't equal. Like Intel's CPUs, for example, use way more electricity and they perform just a little bit better, but they're in the same class. They're still in C tier. So, but if we're talking like HEDT, like, okay, servers, what do we mean by like a server? Like that would be like well, that could just be any kind of server. You know what? Let's add like a triple S tier. This is enterprise. This is also like AWS cloud and stuff like that. Like those who don't know what enterprise could also be like an organization's thing. But this would be an example of this. Rather than saying cloud, would be something like a Cisco UCS. Like Cisco UCS, that would be like more like enterprise. It's considered a server because you can literally just buy a single, like a UCS server or like a Blade server or something, and then that would be enough to be considered a server. But when you pool those together for example, data center or that sort of thing, or if it's used for like an organization in a data center environment, but it's not really like sold as a service, that could be an enterprise. So there's kind of a difference. I guess maybe I should make that distinction. Maybe I should call this like double S tier, and then we'll call like triple S tier would be like data center. I guess. I mean, this is kind of not true in a sense because now we're talking about multiple computers instead of just one computer. So it gets kind of murky at best when you start going above like a typical server, because you know we could be talking about VMs, VMware, virtual machines, all this type of stuff that the typical normies who are only trying to build a gaming PC would have no idea what I'm talking about. So let's just kind of keep it simple, right? So like we'll just say like Cisco UCS as an example, and we'll just, you know what, let's get rid of I mean, we'll just leave it there, right? Like this would be like Dell or whatever. This is like any kind of like server blade or whatever. And then you have workstations. What's a workstation? For those that want to know what a workstation is, that would be like the Lenovo, what is it called? The ThinkStation P520. P520, so this would be like Threadripper Pro. That's workstation. That's honestly, that's like the only like really good workstation on the market right now. Like everything else is basically EOL. Like all of Intel stuff is super EOL. So yeah. So that's gonna be workstation. HEDT is the old, like, this would be like X299 Intel, X399 AMD Threadripper, TR4 Threadripper. So you know the TR4 is like Threadripper 3000 series, X399 is Threadripper 1000 and 2000, and then X299 is like Skylake X. And then if you want to go way back, X99, that was like Haswell E, and then X79 was like Intel's Sandy Bridge E and Ivy Bridge E. So that's like if you're going way back. But those sort of chipsets are the ones that I feel like there's kind of a gap in the market right now. Mainly because Intel abandoned HEDT, just straight up like left the room. Intel has exited the building when it comes to HEDT. Now, they'll still try to sell you like an HEDT, but really what they're selling is Xeons and labeling it as like a workstation. But it's basically like the lowest end server part. Which I don't really like those for workstation, or I don't really like Xeons for HEDT because they don't clock very high. Like they don't have high clock speed. So the problem with going with, you know, like that kind of solution is your single thread performance is really lousy. With like a low power Xeon or something, you know, like you're not gonna get the clock speed. So Threadripper kind of had like a monopoly for a couple of years, since like 2019 to say around, you know, last year or something. But now it's kind of like it's pretty much dead. Like there's no real HEDT, which is kind of sad. So it'd be nice if you know, AMD or Intel, if they're watching this and anybody's listening to this, I feel like HEDT is a market that's underserved right now. Now honestly, there's Threadripper Pro, but again, that's a workstation, and then we're talking like the difference between a $2 to $3 grand HEDT computer to a workstation. Workstations are like $5 grand or more, you know, like, I mean, that's a lot of money. And someone who's in DIY like me or a system integrator, they wouldn't really want to deal with that. I mean, it's hard to get into that market, is what I'm saying. So I feel like it would be nice to have something in this B tier. This B tier, I feel like, is definitely underserved right now. So it'd be nice if we get like an announcement for like Threadripper 7000 series, you know, a year from now or whatever. That would be really, really nice. Or something from derivative of the Epic line, right? Like that doesn't have to be Pro certified, AK workstation grade. So that would be cool. But anyway, so what are we talking about here? So where does X670e fall into? Well, that's going to be your mainstream desktop. So that's going to be this. So this is what we're talking about. This is what AMD is going to launch. And the weird thing is, because you don't have any HEDT options, you're kind of in this weird spot, right? Like if you want to build like a high-end desktop and you want to use it for rendering, work, and coding, like real deal stuff, you don't just want to sit there and play Fortnite with it, because, you know, that's really not what it's for. Honestly, you can do that on a laptop or any random desktop from like 3 or 4 years ago. But if you want to build like a real deal computer that can do a lot of really heavy lifting, you kind of have to go with the upcoming X670e. I mean, if you want PCIe Gen 5, you want a lot of M.2, you want a lot of connectivity, that's kind of the only option. Like, obviously, there is Intel's Z690, and I know we're going to be getting Z790, the revised version of that, but I don't think that's going to be as compelling. You know, I think what's going to happen, and I think there's already like leaks on the internet showing Raptor Lake's performance. Raptor Lake is going to probably like the top 13900K. That sounds really weird to say, but the 13900K is probably going to be a little bit faster than the 7950X. I'm pretty sure. I would be surprised. Let's just put it this way. I would be very surprised if 13th gen from Intel cannot beat the upcoming Ryzen 7000. I expect, I have a high confidence level in saying that Raptor Lake is going to beat Zen 4 in multi-thread and single-thread by a small margin. We already have Geekbench numbers from the internet. I think, let me see if I can find them, but I think there's like an article on WCCF Tech or somewhere that shows, you know, let me see if I can find it. To be honest, I'm more interested in Intel Arc than Raptor Lake. Raptor Lake is gonna be really boring because the problem with Raptor Lake is it's basically gonna throw efficiency out the door and like out the window and just go balls to the walls, full power, you know, Palpatine style electricity, unlimited power, to win the like the single thread contest against AMD. So I feel like in terms of the smart choice, honestly, if you don't care either way, like if you don't have any brand loyalty, you'd be better served going with Zen 4 with AMD than with Intel, just because they have a track record of the chipset or of the platform lasting a lot longer. So like if you're one of those people that only upgrades like 5 years, then it might be a moot point, but it also might not be, right? Because like if you bought in, let's say you bought Zen first, let's say you bought like a 1600 back in 2017, right? Like 5 years ago. You could literally forget about upgrading to Ryzen 7000. You could go and buy a 5800X 3D now for like $399 or something at like Micro Center, or you could just get one off of Newegg for $420 or whatever the sale price is, and then you'd be set for another 5 years. like seriously, you'd be on the same motherboard for a decade. That's kind of insane to think about. But you know, the fact that you can actually do that with AMD and you can't really do it with Intel, because I feel like those who are still on, say, Skylake, like a 6700K, or Kaby Lake 7700K, which is just as old as Ryzen 1st gen, those people who are still thinking that their 7700K is good at games and stuff, that's what I call copium. That's literally a meme. Like 6700K, good luck trying to play like Guild Wars World, like GVG or World vs. World or whatever. Like, yeah, no. Good luck trying to play New World on a 6700K, at least back at launch, because I knew someone that was doing that and it was awful. It was terrible. Like, we're talking like 15 FPS in the cities. So that's copium, guys. People who think that you can still be on a Skylake in 2022 and be fine. But yeah, let me see. 13900K. Where is the thing? I thought there was like a Geekbench article that showed it. Retail. It's like the most recent article. Why can't I find it? Well, hardware. Let me sort by hardware. I don't know. It's somewhere, but essentially the Geekbench results that AMD showed was what, 22,000 for the for the multi-thread, and the leaked 13900K was like 23,000. So it won by like 1,000 points, and then by single thread it won by like 100 points. So you know they're the same 32 thread. So you extrapolate single thread or multi-thread regardless of which way you're going, and you figure out that it's faster. But oh, by the way, you know, you're using like 300 plus watts to do that. So yeah, no. Is this it? Where is it? Why can't I find it? I knew I should have bookmarked that article. I can't find it now. It's so annoying when WCCF Tech like updates their website so fast. 79. Hold on, is this it? No, why is it showing me stuff from like a week ago? Okay, this is it. Alright, let's switch over to this. Okay. So, here it is. So, AMD Ryzen 7950X. Oh, Matteo. Hey, Matteo. The problem with Zen 4 is DDR5 memory prices. Yeah, and we're going to cover that. We're going to talk about DDR5 in a little bit, because that's what I was saying at the beginning of the stream. Like, in the announcement, like, Dr. Lisa Su said that there's not going to be a shortage of chips for Ryzen, and I believe that's true, but the problem with adopting this platform early is going to be securing a motherboard and securing the DDR5 that you want. That's going to be the hard part, not the chip. The Ryzen chip itself is going to be the easy mode part of this. The hard part is going to be getting the motherboard and the RAM. So yeah, you're right, DDR5 memory prices. But the DDR5 memory prices are a lot lower than what they were a year ago. They're still roughly 50 to 100% more. Well, okay. I think if you're looking for 32 gigs of memory on like two 16 gig DIMMs, it's like 50% more than the DDR4 equivalent, maybe 70% more. But if you're looking for like 64 gigs like I am, that's like 100% more money. We're talking $400 for actual like legit expo memory compared to like $200 for DDR4. So for 64 gigs. So the problem with Zen, yeah, the memory prices of RAM is yeah, you're right, exactly. Yeah, that's gonna be the main thing. I mean, and that was the same problem that Alder Lake had. So I think a year ago, the prices were so bad that Intel did make the right decision in being backwards compatible with DDR4, because I think if they weren't compatible with DDR4, no one would have bought into Alder Lake, or like very, very few people. Like less people would have bought into Alder Lake than the amount of people that are going to buy into like AM5 and Zen 4. So, but yeah, but the thing is, the prices have come down. And they're only just going to go lower and lower, unless something bad happens and we go into like another supply shortage next year. But here's the thing. So like my takeaway on this, so somebody leaked the, right here, someone leaked the Geekbench results, right? So 2200 single core, 2400 multi-core for the 7950X. And then if we go look at the leaked Raptor Lake, so 13900K, the leak was like 2300 on single core, 2600 on multi-core. So this, to me, just looking at this, AMD already won. And people are going to be like, how can you say AMD won when Intel has the longer bar, like the higher score? Well, because the power consumption, I know the Raptor Lake power consumption is going to be really, really high. Guys, don't believe me? I already know. You know, see what this is? You guys know what this is? This is a 12700K. This is my 12700K. I purposely chose to get this Alder Lake instead of the 12900K because I'm using a Noctua NHD 14. I do not want to run liquid, and I do not want to have to buy one of DeBauer's or somebody's little thing from China to fix the heat problems on Alder Lake. No, for the mounting pressure. I'm not going to do that. I'm not going to mess with that at all. So I had to buy the 12700K because the 12900K is going to overheat on my Noctua cooler. My big NHD 14 can't handle that thing because the mounting pressure on Alder Lake's IHS is horrible, and the thing uses 241 watts in PL2. So that's the reason why I am going to Ryzen 7000. 350. Yeah, it's too much. It's too much. And I already know it's going to happen because they even, like, the only way that they can win against Ryzen 7000 is by upping the power. That's the only way. There's no other way they can win. Raptor Lake is literally just, if we're talking Intel TikTok strategy, it isn't even a tick. So TOC is a new architecture. So that was basically Alder Lake. Tick is supposed to be a node shrink. Well, Intel's not shrinking the node for Raptor Lake. Raptor Lake is going to be the same node as Alder Lake. It's a revision to Alder Lake. And all they've done is they've upped the cache. So that's going to improve, like, you know, performance just because the cache goes up. But what does that also do? That ups the power because cache uses a lot of electricity. So that's going to generate a lot of heat, small area, poor mounting pressure. You know, Intel is so sketch with their, you know, I guess they use solder now, but there was a period of time where Intel was like cheaping out and using like thermal, like they were using like thermal paste between the IHS and the actual CPU die. I think it was like Ivy Bridge. This was 10 years ago. Ivy Bridge, Sandy Bridge had solder. Ivy Bridge did not. Haswell did not. It was horrible. Then they made Devil's Canyon, aka 4790K, and they improved the TIM. They put new and improved TIM, but that wasn't actual solder. And then I don't think they finally went back to solder with like Coffee Lake or something. I don't know when or maybe it was the 9900K Coffee Lake Plus or whatever it was, or 14nanometer Plus or Plus. I can't remember anymore, right? So yeah, I mean, they have their own struggles, and you know, they got a lot of money that they'll survive. I'm not worried about Intel. I'm interested in ARC. I want an A770. I've been waiting for an A770 from Intel pretty much all year. Ever since that YouTube trailer back in March, I've been waiting for that GPU. I don't want an AIB. I want the one that Ryan Shrout showed off on the WAN show. That's the one I want. I don't want any other model. I want the stock Intel reference one, and I want it now. I do not want Raptor Lake. I do not want any other CPU garbage from Intel. I mean, the great thing with Raptor Lake is i7 16-core, i5 12 10. Oh, I mean, I don't consider it 16-core, man. I'm sorry. I don't consider E-cores like real cores. Like, no. It's like I've got a 12700K and I've turned off all my E-cores and I never ran them ever. Like, I ran them for like the first few weeks that I had it. So I bought this thing on launch day, November 4th, 2021. I went to Micro Center. I bought this, and I bought a Gigabyte Gaming X DDR4 motherboard, and I was so displeased with the motherboard because when I was in the store, I asked them, I need a DDR4 motherboard, and I need the motherboard to have, you know, XYZ features. One of them being Dr. Debug. Where's my LED output telling me my debug code? Like, if it's not posting, I want to know the error. Is it D0? Is it, you know, 00? Is it a memory problem? Is it a VGA Connect problem? You know, where's my Dr. Debug? Well, guess what? There isn't a single DDR4 Alder Lake motherboard that has a Dr. Debug on it. Intel, what are you doing? Or I guess maybe I should blame the AIBs. What are you doing with the DDR4 motherboards? They're trash. DDR4 motherboards on Alder Lake are considered second-class citizens. I'm very displeased with my Alder Lake experience. This is probably the worst CPU experience I've ever had. Worse than first-gen Ryzen. I'll tell you why I turned off the E-cores. I played Endwalker at launch, Final Fantasy XIV Endwalker, one of the most popular, the best MMO in the world. I played it December last year. After playing, if you're playing the game for like 3 hours, or it could be 3 hours, it could be 6 hours, it could be 9 hours, whatever. Randomly, the game will crash. DX fatal error has occurred, and the game crashes. Oh, by the way, we've got 3-hour queue times to log into Gilgamesh. Every time I would crash to desktop, I would have to sit in queue, and that would be the end of my play session. So I was not thrilled with that at all. I went back to my 5800X AMD Ryzen 7. Never had that problem. What did I do to fix it with Intel? I tried updating the BIOS. It didn't fix it. I tried, various other things. It didn't fix it. What did I do to fix it? Guess what? I turned off all the E-cores and the problem is solved. There you go. I don't consider E-cores real cores. I mean, I know it's just one person's experience, but I don't like them. I think they're great for mobile. They're great for like low power, battery powered stuff. For high-end desktop, no. I don't want them. I want real performance cores. So literally, like for me, 12700K and 5800X are literally just 8-core 16-thread CPUs. I don't use the E-cores. They've been turned off pretty much since December of last year. I've never used them. So disappointing, I know, but not thrilled. I mean, people probably think I'm hating on Intel. I mean, guys, I used Haswell i7 4770K. There's videos of it on my YouTube channel from way back, and I was on Haswell until Ryzen first gen came out. I bought the 1800X, the Crosshair X370, and never looked back. I mean, I decided to get Alder Lake, and people are going to be like, well, why did you go back to Intel if you knew the E-cores were trash? Well, first of all, I didn't know that the E-cores were trash, or would cause weird instability problems. And people are going to point out, well, they were supposed to have fixed that. And by the way, I'm using Windows 10, not Windows 11, so that might be the other problem. But maybe this doesn't exist with Windows 11 because it has Thread Director. But the reason why I bought Alder Lake is because I was waiting for Threadripper 5000 series, and it never came out. So AMD went Threadripper Pro only, which is workstation, too much. B660, 13, 400, and DDR4 memory seems to be the best budget now. I mean, I guess. I don't know. I mean, when I look at those CPUs, I ignore the E-core counts. They're dead to me. So it's like, so what is that? Like, what is that supposed to be? 13, is that supposed to have like no E-cores or something? 13600K is, I don't even know what it is. Like, is it a 8-core 4-thread? Is it like a 6-core 8? No, 6. Is it a 6+8? See, it's so hard to keep track of them because you got to figure out which ones have the. Let me see. I gotta find them. Let me find the Alder Lake, or let me find the Raptor Lake stuff. Meteor Lake? No, not Meteor Lake. Is it this one? Okay, so the 13600K is a 6+8. So it's okay. It's what I thought it was. So it's 14 core, 20 thread. So it has the same thread count as the 12700K. The only problem with it is it's 6+8 instead of 8+4. If it was 8+4 like the 12700K, it probably would have been better. Because I'd take two more performance cores over like 4 more E-cores any day. So actually, was the benchmark? Wait, where is that article? Like do they have the 13600K on here? Oh yeah, they do. So okay, so they're showing that it beats the 12900. I mean, it's like basically the same as the 12900K. And it's got the same amount of E-cores and 2 less P-cores. So that does show that shows the efficiency, or that shows the improvement there in the core, going from Alder to Raptor. But honestly, when I look at this, I just think the AMD stuff just looks better on paper, because it's like like DDR4, yeah, I guess, but I don't know. If it works out, it works out. But if you run into like an application that doesn't like E-cores and you're on Windows 10, good luck trying to fix that. I mean, and keep the E-cores enabled while doing that, because yeah, I don't know. It could also be like my motherboard, Gigabyte motherboard, just might be bad. But you know, I play other games on that system, and I never, with the E-cores on, I didn't have problems. Like Genshin Impact never crashed. You know, some other games like Tower of Fantasy doesn't have any issues. with E-cores being enabled. But I don't know. Final Fantasy is just very sensitive to like memory latency or something, and I think the E-cores have worse response time. If the game thread gets randomly assigned by Windows 10 over to an E-core, I mean, most of the time it's fine. It's just like I said, every so often the game will just randomly crash to desktop with a fatal DX error, and no other game does that, and it only happens on Alder Lake, and it only happens when the E-cores are turned on. So, yeah, I don't know. But anyway, so let's talk about the what was I gonna say here? So, oh yeah. So the DDR5 is gonna be really expensive, but I want to get through the motherboards first. Then we'll talk about the DDR, because there's a lot of stuff to go over on the DDR side. But I think so in terms of these. So out of all the motherboard brands, and this is just talking like in general, not necessarily X670e, because obviously these aren't out yet, so I can't really talk to any of these. But in my opinion, like I was saying earlier on, I feel like Asus has kind of priced themselves out of the market. In my opinion, they're just too expensive, and they have things I don't care about. Like all this random like RGB matrix dot display stuff on the heat sinks. I could care less about that. I just feel like that's a big waste of money. I know some people care about that, but for me, my computer is sitting on the floor. Like, it's right here on the floor. You guys can't see it, but it's underneath on the floor with and there's a wall here. There's literally a wall, like, right here where my hand is over here. And the side panel is up against the tempered glass is, like, up against the wall, so I can't even see the machine. So all this RGB stuff is nonsense to me. So it's like, I don't care. So now obviously I'm just giving my opinion, but you know, it is what it is. So I like Asus. I am currently running an Asus Crosshair 8 Hero Wi-Fi with a Ryzen 5800X. That is what I am using to stream right now, for those wondering. With 64 gigabytes of DDR4 G-Skill Ripjaws from Micro Center. 3200 mega transfers. I know people are gonna be like, why aren't you running 3600? Because I bought this RAM like back in Ryzen 1 era, and I never bothered to change it. So so Asus is kind of out in my book. Although if you like them, if you never had a bad experience with them, and if you're okay with like overpaying essentially for gimmicky stuff piled on top of like the essentials that you actually will use, then I guess it's okay. I won't say that you shouldn't get it. I just say I'm probably not going to get them this time around. Now, the one that I am interested in the most would be MSI. So MSI in the last couple of years has really come through. So when I went to Ryzen, my first Crosshair on launch day was defective. It had that bug that kept trying to boot up and update the BIOS over and over again. There was no way for me to fix it because it wouldn't let me do the flashback. So I literally had to go back to Micro Center, return it, and the only motherboard they had in stock was the MSI X370 gaming. The X Power Gaming Titanium. It's the motherboard that looked like it was cookies and cream. It was like a silver motherboard with like black spots on it. It was cool looking. It was really weird looking. But that was what I ended up with on launch, and then eventually I did get another Crosshair and go back to Asus. The MSI board was the most expensive board. It was like a $300 board with a pretty lousy VRM, and we did overclocking on stream way back. With the MSI board and with the Crosshair 6 Hero. Did a couple of streams like years ago. You know, this was back in 2017. But over the years, I feel like MSI has really stepped up their game. I feel like their designs have gotten a lot better looking. They still have the dragon thing, which is still kind of their cool logo thing now. But they've segmented like MEG, so they got Meg, MPG. I think Meg is like the enthusiast grade, or enthusiast gaming, and then MPG is the performance gaming. That's like the tier below it. So the way I see it, Meg is like ROG, MPG is like Strix, and I forget what the one underneath MPG is, but they have another one. It's the Essentials one, which is basically like Prime on the Asus side. So for those coming from Asus or wanting to know like what are the equivalents from MSI. But honestly, guys, this motherboard right here, the Ace, is probably my top pick for motherboards for like launch. Like if you're going enthusiast like me and you're gonna go, doesn't matter how much it costs, you're just gonna buy it. I mean, assuming it's not like $1,000. If it's $1,000, then yeah, forget it. But if it's like, you know, like 450, you know, I mean, I'll do that. I'll do 450. I'll even do probably 500 on this board. But so when we start going above $500 on a motherboard, that's when, you know, eyebrows start raising and people are like, are you trying to scam me? Is this a scam? Yeah, that's when that starts happening. So I don't know about 500 plus, but I'll say, like, if this is $499, I'm buying this day one. If it goes beyond that, though, we might start like reevaluating if we're doing the right thing here. You know what I'm saying? Like, we're probably gonna be looking at MPG or maybe Asrock or somebody. Like the Tai Chi might be showing up, or maybe that Biostar. Let's talk about Biostar real quick, because I feel like Biostar is really like came out of nowhere. Anybody who watched that Meet the Experts, like they had probably one of the most interesting motherboards that they showcased, the Valkyrie. Now this thing looks pretty nice. Like in terms of everything that I want on the board is here. It's got the Dr. Debug down at the bottom, which is fine. At least it has it. It has 3 full physical X16 slots. Now I know that the first and the second one are going to be wired for X8 if you're running dual GPU, or if you're running GPU plus like an expansion card. But you still have like your X4 electrically wired X16 slot down there for your AverMedia capture card if you're a streamer, or if you're running Elgato, you know, whatever, same deal. You got the 4 DIMMs with the metal brace thing here. You got the LGA socket, of course. You have AMD's typical removable socket thing that everybody removes because no one's going to be running a Wraith Prism on here. And then you've got 6 SATA, you know, the 24-pin. I see the USB 3 front header. I see the USB 3.2 front header. I mean, like everything here. 8+8 for the CPU. So it's going to be real stable. I see the Wi-Fi. Let's look at, do they have a picture of the, yeah, so, I mean, even this is good, man. They're giving you, like, all the right things, Biostars. They're coming through. You know, you got all your USB Type A. You have the Type C there on the back. So, unfortunately, it would have been nice to see another Type C for, like, a 20 gigabit USB port on here. But, unfortunately, I don't see one. But they do give you the full audio. Like, Gigabyte has really gimped out on the audio, like on the 5.1. Gigabyte on almost all their Alder Lake boards. I think every single DDR4 Alder Lake board from Gigabyte was literally just the 3, like the essentials. They gave you the mic in, the line out, and they gave you, or line in, and then your headphones. So, like, they only gave you the 3 essentials, and that's why that's why I'm saying, like, all the Alder Lake DDR4 motherboards are second-class citizens. None of them support multi-GPU, so no SLI. I know that sounds like a gimmicky thing that no one cares about anymore, but, you know, you can't do that on any of the DDR4 boards. In fact, you can't do that on pretty much almost all the boards, except for, like, the Unify from MSI. So, I guess the only other one is, like, the ROG Extreme from Asus, but you know, they're giving you like the display port, the HDMI, the BIOS update, you know, everything that you need. 2.5 gigabit LAN. You got the Wi-Fi. I mean, what's the Wi-Fi on here? It doesn't really say. Caution, the picture, so it should change. CPU, nothing's here, so they don't really tell you a lot, but they do. It's a nice looking board. I think it's a solid option. I mean, the main thing that's questionable about Biostar is the support, because, you know, they're not as well known outside of China. So China and the Taiwan market is pretty much where Biostar is really, really strong. They might be good in Japan. I'm not sure. I don't remember seeing them when I was over there, but you know, it looks like a good choice. It depends on what it costs. Like, if everybody's gonna be selling X670e for like $500, and then here comes Biostar with the Valkyrie for like you know, 250 or 300, I'll probably buy this. I mean, this looks like the VRM looks pretty good. I mean, well, what I can tell, you know, like they have the back plate, you know, everything is here. Like nothing's omitted, right? Like, and here's the thing, like, what we got here? 2, 4, 6, 8, 9. We got 9 USB Type A on the back. You have the Smart BIOS plug or USB port on the back. So think about it like this. In my case, ideally, I want to see 9 to 11 USB Type A on the back, because that allows me to run like pretty much everything I can think of, right? Like let's count how many devices someone would plug into the back of their motherboard. So let's count what I have: mouse, keyboard, microphone that I'm using, the webcam that I'm using. That's 4. The Xbox game controller. That's 5. I used to have an Elgato HDS, so that would be 6. And then what else we got? Oh, and then if I had my VR headset connected, you know, if we're talking the old school Oculus Rift, that's 2 sensors, which each use a USB port, plus the headset. So there we go. We're at 9 USB ports required on the back of the motherboard for my setup. Now, if I'm running the newer VR headset, like the Oculus Rift S, now that has the inside-out tracking, so that one would only use 1. So you'd reduce the USB count down to 7 ports needed, but that's still a lot of USB needed, right? So this is the reason why, like, if we're talking enthusiast stuff, this is why more is always better. It's better to have it than to not have it. Now, I know you can plug stuff into the front, but that's typically where I would plug in like USB thumb drives, you know, things that are not going to be connected all the time. That's usually what I reserve for the front panel on the case. So that's why I wouldn't leave things permanently plugged in there, because you never know when you might drop something from your desk and falls, or you just smear off the USB port on the front of the case. So no, I consider those temporary connections. So so this is a good motherboard. Like, it honestly looks really solid. Like, I'm actually impressed. I know Biostar had the worst presentation in the Meet the Experts, but the product was good. I can't really criticize them. I mean, I've never used them before, so I don't know how their support is. But, you know, if it's a good quality product, then there's really nothing bad to say. You know, it looks like it's going to probably be decently priced, too. And it has all the features. So, you know, if this thing is $300, you know, they might sell a lot of these. Who knows? But this is still my top pick. So the Ace is still, like, the most ideal board in my mind, in terms of like the functions you have. You know, like you have the big, I like how they went vertical on the main Gen 5 SSD slot, and then they have the other ones down there. You know, you got the Wi-Fi, you have 8 USB Type A, you have your DisplayPort alt mode on USB-C on the back, you have 2 more USB-C. I think all 3 of those are 20 gigabit. So I think this is a good segue to go into the actual chipset details, so on the socket. So I think a lot of people are probably going to be curious about that. So Tech Power Up did publish a really good article that has a very, very good diagram here for the chipset. So X670e, it's going to give you, essentially it's 28 lanes of PCIe Gen 5. Where 16 of those, the first 16 go to the primary GPU, and if you plug in a second, like a second add-in card or a second GPU for SLI or Crossfire, then that makes the primary one bifurcate down to by 8, and then the second half of it goes to the second slot for by 8. So you have 2 by 8. Anyone who's done multi-GPU understands how that works. It's the same deal with the X670e chipset. So you've got, you know, it splits, or the motherboard splits it, so you got by 8 by 8. So that's going to be this first one here for the GPU slot. Then you have what they call the general purpose PCIe slots. So that's the second and third column here. So 16 through 19, and then 20 through 23. So one of these will be typically for your M.2 drive. So 4 lanes will go to the M.2 drive, and that's going to be where you want your boot drive to be plugged in. So that's going to be, you know, the primary M.2 slot, and that's going to be Gen 5 capable. So that has an upgrade path to PCI Gen 5. So that's real nice. And then you have another 4 lanes that will be reserved for however the motherboard manufacturer wants to allocate that. So I think, so here are the choices for the motherboard manufacturers. So they can either they can add Thunderbolt, so they can put something called the Intel Thunderbolt 4 controller. So this is the JHL 8540 Thunderbolt 4 controller. So if a motherboard vendor, like let's say MSI or Gigabyte or whoever, they wanted to advertise Thunderbolt, because I know Asrock has done this in the past. I think they're the only one. Asrock was the only AIB that brought Thunderbolt to AMD CPUs in the past. I can't remember exactly if it was on X670 back in 2019 with Zen 2, or maybe it was on a Threadripper motherboard. I can't remember exactly the details, but Asrock did bring, not Thunderbolt 4, because it's the latest one, but at the time they brought Thunderbolt over to AMD. And the way they did it was by, you know, getting the Intel chip and connecting it. So that's basically what they can do. So there could be the option to run native Thunderbolt 4 via the JHL 8540 on the X670e motherboard. So they could do that because they could use, you know, for example, 20 through 23 on the PCI lanes. They could do PCIe tunneling to and wire those up to the Thunderbolt controller. So you could get Thunderbolt 4 on an AM5 motherboard. So it's a possibility. So I'm just pointing that out here. That's one option. Now the other option, rather than going with the Intel Thunderbolt, they could go with the, and this is probably going to be more likely, they could go with the ASMedia USB 4. So that is the 40 gig, the 3x2 on the USB-C gen from ASMedia. ASMedia, there's a Taiwanese company that builds like custom silicon controllers, typically for things like USB and peripherals and stuff. So they could go with that, and AMD has partnered up with ASMedia a lot, basically since Ryzen first gen. And even further back, because I think like the crosshair on the FX 8350, like the crosshair 6 or crosshair 5, had like an ASMedia to bring USB 3 to like Bulldozer, for example. That's just a little bit of history, but you know that shows that AMD and ASMedia go way back. So they could put ASMedia USB 4 on this general purpose PCIe 5 connection here. So that would be another option. So they could either go Thunderbolt 4 or they could go ASMedia USB 4. Now the third option, which is probably the more realistic one, is they'll give you another M.2 slot. So, you know, they'll advertise the motherboard with 2 Gen 5 PCIe NVMe drives, M.2 drives. So they could do that too. And honestly, guys, I think that is going to be the most common scenario. Like, I feel like they're mostly going to probably do that. I think it's going to be very, very rare to see the Thunderbolt option on here. I'm not saying that they're not going to do it, but I think it's needed. But you know, they might just cheap out and give you another M.2 port, because I think that's the easiest, most cheap option there. The other two would cost more money because they have to essentially buy the controller from either Intel or ASMedia and integrate that into the board design. So, but that's basically your 24 lanes of PCIe 5, and then the 4 extra lanes go to the chipset. So the 4 mains, remember there's 28 of them. 4 of them go to the chipset. So 24 are your what we call CPU lanes, CPU PCIe lanes, and the remaining 4 go to the chipset. So if we go back to the diagram that I had shown here, so we have right here, we have a this is X4 or PCIe X4 or PCIe 5 X4 lanes. Those are the remaining lanes. They go to the chipset, and that's how you're going to get all your other connectivity. So those 4 then split out, because, you know, one PCI Gen 5 lane is like 2 PCI Gen 4 lanes. So it's kind of like PCI, like X8 Gen 4. So what that means is that the bandwidth improves from the chipset to the motherboard, because you have Gen 5 now signaling as opposed to Gen 4. Now that's going to require more retimers and things like that. That's probably why they have another chip down there. Like there's like the actual 2B650s, and 2B650s equals X670. So what I want to write over here real quick. So when building a computer for, I guess, Adobe AE, typically you want RAM. You want RAM to equal 4x CPU cores, and then you want VRAM to equal the number of CPU cores. So this is like a rule of thumb when building a computer. If you want to build a balanced computer that will last you a really long time, well beyond the warranty, well beyond the CPU's life, and even well beyond the socket's life, typically this is what you want to build for. So you would do, you know, like so for example, 7950X equals 16 cores. That implies 16 times 4, 64 GB RAM, right? So I hope people understand what I'm saying here when I'm deriving the memory. I'm basing this off of Adobe AE. Like this is their recommended guidelines when they build computers, or what they recommend, like clients for, or content creators that are going to build stuff to use their Adobe suite. So the VRAM also, right? Like, so if we have 16 cores, 16 cores implies 16 GB VRAM, implies Radeon RX 6900 XT or 6800, 6900 XT, right? Because those, or Radeon 7 or something older. But like typically this is what I would say, this is what I would consider a balanced build, right? Like this is a balanced build in terms of spec. This is the reason why I've always seen NVIDIA as kind of shortchanging their users, because they don't really like. Typically, the type of CPUs that would get paired up with NVIDIA GPUs have more cores than NVIDIA has VRAM, you know, etc. Like the one exception, obviously, is going to be 3090 and 3090 Ti. But how many people are actually going to be running those type of GPUs, right? Like not a lot of people. So, like less than 1% of the total market. So it's very, very niche product, niche use case there. But that's why I feel like the RTX 40 series is probably, we're going to see SKUs from NVIDIA that finally have 16 gigabytes of memory that match up with like a 16 core CPU. So that's kind of the rule of thumb. Okay, so that's going to be that. Let's now go back to this. Display outputs on the integrated graphics on the new Ryzen 7000 CPUs. It says here that the USB 3.2 Gen 2 ports on the back, 3 of them, so the 0, 1, and 2, the first 3 support DisplayPort alt mode. Oh, actually, okay, that's the blue. That's the blue over here. So what this means is that the AM5 interface, so that means the pins on the socket, there are pins on the socket that can address all of these different aspects of the chipset, of the motherboard itself, right? Because the motherboard is not just the chipset. only 4 lanes from the CPU go to the chipset. The rest of them go directly to things that connect to the motherboard, whether that be the graphics card, etc. The display output on the back, so it has pins. What this means is there are pins out of the 17, 18 pins on the back of the CPU. There are pinouts for up to 4 displays. Now, those can either be wired for DisplayPort, HDMI, or even DVI. So those are the options. What it also says here, so see in the blue where it says USB 3.2 Gen 2, there are 4 USB 3.2 Gen 2 ports that natively connect to the CPU. Of those 4, the first 3, so the one with 0, 1, and 2, that's what it says down here, support DisplayPort alt mode. So when I look at a motherboard like the Ace, for example, now I know on this motherboard, let's just click on specifications. So this motherboard, well, it's kind of hard to show it here. Yeah, here we go. So this motherboard has 3 USB-C ports on the back, but only one of them, this one right here, has the DisplayPort alt mode logo on it. And I think MSI even says that only that one right here. So back panel ports, port 9, USB 3.2 Gen, this is a 10 gig that supports Type-C DisplayPort. So this is DisplayPort alt mode. So only this one, so this motherboard only wires one of them. So if we go back to this Tech Power Up article, that one on the back is one of these 3. Now, where the rest of these 3 are, I don't know. More than likely, what they've done is they've wired those other 2 to the front, or maybe one of these is there, or maybe this is another one, and they just either they don't support the DisplayPort on there, or they have it turned off in the BIOS. So again, it's going to depend on what the BIOS supports, and this is why some motherboard manufacturers are preferred over others in a lot of different use cases, because some of them, have features that others don't. This is how they differentiate themselves from each other, and that's how you get competition in the motherboard space. So it's kind of disappointing. Like, it's kind of a bummer that they only have one of those USB-Cs wired for display out, and they don't have any other display out. So what that means is that the orange section of the AM5 interfaces is completely unused on a flagship motherboard. So that's really, really disappointing. If we look at Asus, let's see if we can get a picture of I want to see the I/O. Do they show it? Like, okay, they don't show it. Okay, does the Hero have it? Okay, Asus is failing hard right now. Like, I don't see any. Okay, the Hero shows their I/O. Okay, so the Hero has an HDMI, and it looks like they've got Thunderbolt. They've got Thunderbolt on 2 of these, and they got the one here. Wait, 2, 4, 6, 8. So the same amount of USB Type A that the Ace has, but what they've done better is that, well, I don't know if it's better. They have an HDMI on the back instead of the USB-C that the Ace is using. So the Ace has the port 9 on the Ace is a display out, but the other 2 aren't, which is really weird. I mean, why aren't all... I don't know. It's weird. I don't know if they're reserving that for front panel. I don't see... So they got a quick charge. They got the power one on the front. It doesn't really say. Again, I'll have to look at the manual to figure out how that's going to work. But that's kind of disappointing. I like their I/O on the back. Like, they have the 10 gig NIC on there, and they have the AMD Wi-Fi. What's interesting is that they are actually implementing the AMD Wi-Fi. That was another thing I was going to talk about. AMD actually has Wi-Fi 6E now. This is actually AMD Wi-Fi, not like Intel Wi-Fi or Realtek or, some Broadcom chip or something, which is really weird. I mean, there's a news article about it, but I think on the Hero, what's weird, so it looks like they have Thunderbolt on here. I think the Hero has Thunderbolt. So, and guys, if it's too loud, if my microphone's too loud, let me know and I'll adjust the volume. Actually, let me go ahead and there, I've made it lower. Well, there, I made it even lower, so I can't, like, burst people's ears or whatever. So hopefully that's better. What I wanted to say on this is Intel Thunderbolt. Oh yeah, right there. 2 Intel Thunderbolt 4 ports, USB Type-C, support DisplayPort 1.4 and Thunderbolt video outputs. Oh, okay, that's very interesting. So Asus is back on my radar now because they've implemented this. So the Hero, is this the Hero? Oh no, this is not the Hero. This is Z690. This is Intel's board. Oh, that's not what I wanted to see. Tech specs. Because if they give you another... Okay, Asus just pretty much is failing hard right now. There's a Marvell. So they're going with onboard Wi-Fi 6E. They don't say what. The Marvell AQ 10 gig and the Intel 2.5 gig. Ultra fast connectivity, PCI Gen 5, the Gen Z.2 card, Gen 5 M.2. So I don't know what that does. Is that going to downgrade it to Gen 4? The Gen Z.2 card. There's just not a lot of info. Oh, okay. They do go with USB 4 ports. So they went with USB 4. So if we go back here, I don't know if that's this or not. That's probably not. That's probably ASMedia. So it looks like Asus has gone with the ASMedia controller. I don't see Thunderbolt listed here. Remember, Thunderbolt is a PCI... Thunderbolt is actually PCI Gen 3. It's based off of PCI Gen 3. But it looks like they opted for USB 4. That's interesting. So their top-end SKU, so the Extreme doesn't actually provide support for Thunderbolt. That's kind of disappointing. So this one, they don't have the stuff yet. So if we look at Gigabyte, Gigabyte has, let me see, next gen storage, PCI Gen 5, X4 M.2, 4, okay, they're saying 4 PCIe 5.0 X4 M.2 connectors. So that means that they're using the one that they typically would, and another one. And that means that the other two are bottlenecked through the chipset. That has to be the case. I mean, that's the only way it could work physically. So, which is fine. I mean, that's fine. But it's just kind of jarring that nobody so far, let's look at Asrock. Nobody has Thunderbolt. At least none of these SKUs. I would have thought that the Extreme would have had it, but wow, I'm surprised that neither the Gigabyte Aorus Extreme or the Asus Crosshair Extreme have that. Okay, Asrock is doing weird stuff here. They're going with the killer E3000G 2.5G. That's a Realtek LAN. I would have rather had an Intel LAN instead, but it really doesn't matter. When we're talking Ethernet, it doesn't really matter. It's really Wi-Fi. If you're going to use Wi-Fi, then it really does matter. So this one is using the AX, whatever this is. So, I don't know. They must have got like a good deal, a good discount on like their network stuff that they're using from Realtek, because that isn't even the stuff that like AMD recommends on there, so that's odd. But you know, some people might not care or might not pay attention to that. So their I/O is kind of, it says Lightning Gaming on these. I don't know what that means. That looks like Thunderbolt. I see the Thunderbolt symbol. Well, that could be the power symbol. There's the 2.5. There's an HDMI. Just kind of strange, right? Like only 6. They have 4 USB 3, the 5 gig. They have 2 10 gig type A's, and then I guess these are also 10 gig. The Thunderbolt. I don't know. There's a 6E Wi-Fi. I don't know, man. The Tai Chi looks really bad right now. Like it. This can't cost more than like 380 maybe 350 349 for this. Like it. I mean, what's with this empty space right here? Like, put more USB ports here, or put like a PS-by-2 keyboard or mouse plug-in right here. So something needs to go here. Fill this up. This doesn't look good. And also, they're gimping on the audio. This is like the Gigabyte. This is like the Gigabyte Z690 boards from last year. The DDR4 Alder Lake boards. Like, I don't know, man. If this is a flagship board, this doesn't look good. Like, the audio is not 5.1, which is, it's like, okay, I can live with that, but at least give me more USB Type A, or give me like a DisplayPort out, or give me something else. Like, this is very anemic. Like, where's the stuff, right? Like, all of these are like 5 gig. Oh no, those are 10. These are 5. So okay, so there's 4. No, there's 3 Type A 10 like USB 10, and then there's like, or USB 10 gigabit, and then there's like 3 USB 5. Like, what's up with why is it so strange? Like, I don't know. It's just weird. Okay, and then so this one, I know it's gonna be really expensive. They're going with Marvell? No, they're going. I don't know what this is. They say onboard Wi-Fi 6E. They don't say if it's AMD Wi-Fi 6E or if it's Intel Wi-Fi 6E. Like if it's the AX200 from Intel, or what are they using? They have an Intel NIC. They have a 10 gig, a Quantia. Okay. Ace seems to have the best documentation so far. Like, by far, like, this is the most, and the way it's organized is the easiest to read, but it's still missing certain info on here. It's still kind of a bummer. There's only one. There's no HDMI on the back. There's no DisplayPort on the back. So the only way you can get like video out off of the integrated graphics is to connect to one of the USB 10 ports that is using DisplayPort alt mode. So one of them is wired the way it says in the reference sheet, but I don't know. So right now, the best looking one, after just doing analysis on all of these, is the Ace. I mean, you're getting the expander card, so yeah, if it was me, I'm probably gonna go with this. This is the best one so far. I mean, unless Asus can update their product page and put like more details on what some of this stuff is. There's the DAC. Okay, that's cool. But like, wait, is there Thunderbolt? Is there USB 4? Like, okay, there's USB 4. So does that mean they're using the 4242 from ASMedia? You know, like, those are the sort of details that are lacking here, and the tech specs are basically, you know, non-existent. So, yeah, okay, that's real helpful, Asus. Okay, all right. So anyway, that's the motherboards. Now let's talk about DDR5. Because I think DDR5 is going to be the biggest barrier to entry for adopting this new platform, more so than the motherboards and the CPUs. I think the CPUs are the easiest entry point. Motherboards are kind of hard because, you know, the initial chipset is going to be really expensive, but not crazy expensive like I think everyone's thinking. DDR5 is going to be really expensive. So if we talk about DDR5, right? Let's bring up this article from WCCF Tech. So G-Skill unleashes AMD Expo, Infused Trident Z5 Neo, and Flare X5. So they're doing the Flare X. I'm glad they're bringing Flare X back, because this is a throwback to the old, like, back when AM4 launched, G-Skill did Flare X on there, and those are, like, really good. Those are the Samsung B-Die. So I expect these to have similar, I guess it's A-Die, or maybe, I don't know, something that's not Micron, but something useful, maybe Hynix, this time around. But anyway, G-Skill has announced its AMD Expo. You know, honestly, guys, I don't know why AMD had to come up with a new acronym. For those that don't know, AMD used to have something similar to XMP. Back in the FX8350 days, they had something called AMP, AMD Memory Profile. So they had AMD Memory Profile, or AMP, way back, like pre-Ryzen. Then it went away. Ryzen came out and they just kind of didn't address it at the time. So it was really only like a DDR3 thing, the AMP. But now they went and brought out Expo. I feel like they should have just brought back AMP, to be honest. I think that would have worked. But whatever, Expo. So G-Skill has announced its AMD Expo ready Trident Z Neo and Flare X5. I personally probably going to go for the Flare X5. I don't care about RGB. And these tall heat sinks, I would much rather have low profile heat spreaders instead. So I'm probably going to go with the Flare X5. The Flare X5 is probably also going to be cheaper. If we look at, there's a really good chart here. There we go. So this is what we need to look at when we're thinking about what RAM to get. So it looks like the Trident Z5 Neo is, and the RGB is going to be the one that offers the more higher end stuff, so to speak. So the DDR6000 with CL30 at cast latency, so the timings would be like 30, 38, 30. So this top one here, that's probably going to be really expensive. Although the thing is, the capacity is only 16 gigs. So this is probably going to be like $250. Yeah, probably like $250, maybe more. I could be wrong. If we try to search like DDR5 6000, right? Like let's try to find man, why does Newegg have to make this so dumb looking? Where's the memory? Let's search by like desktop memory. So if we try to search by DDR6000, here's a Z5, right? So the Z5 RGB 32 gig. This is, let's do quick view. 36, 36, 36, 96. 1.35 volts. Did they say the voltage? So, wait. Quick view this again. 36, 36, 36, 96. Okay, so that's this one. So that's basically this one that you see right here in the middle. That's going for $240. So yeah, that's like double the price of DDR4. DDR4 like 3600 right now is the same equivalent. And that's for 32 gigs. That's like $100, somewhere around there, I'm guessing. So yeah, it's pretty much 100% markup compared to DDR4. So this is definitely going to be the biggest barrier to entry, right? Like this is probably, and the timings on this aren't even that good. Like if we try to do, like, okay, let's look at the real stuff. Let's look at what I would actually get. So I would consider 5600 or 6000 for 32 gig per module. So let's sort this out. And let's pick one of these. So the cast latency, let's go with like cast latency 30. Or actually, hold up. So the way I calculate it is I take the mega transfers. So if I'm doing 5600, I would do 5600 and I would start dividing it by one of these numbers. So like for example, 5600 divided by 28 is 200. So that is equivalent to, I think 36 by 16. No, that's not as good. 32 by 16. So, okay. So this one right here, right? You can get a Flare X5 with the cast latency 28, the timing is 34, 89. This is somewhat comparable to DDR4 3200 CL16, right? So if we go back here, and let's just get rid of 6000 for now. We'll come back to that, and let's do cast latency 28. Let's see what we can get. All right, see, there you go. So they already got them. The Z5 RGB is already there. Now I think they're calling them the Z5 Neo, but I think all this is G.Skill's QA team literally like checked that these support like the Expo profile. Now I don't know what the Expo profile is going to look like, but I'm guessing they're going to have timings like this, unless these are just JEDEC. If these are JEDEC timings, then I have no idea what the Expo timings are going to be. But you know, they're saying like 6000 DDR5 6000 gets you that 1-to-1 ratio on F clock, so that means that that means that's going to be equivalent to like DDR4 3600 on like X570, right? So here, let me make a chart. Let me make a visual real quick in Paint for those tuning into the stream so they know what we're talking about. So we're talking about memory now. Let me just go ahead and add down here DDR4 to DDR5 conversion, right? So there's probably people that are wondering like, well, what do I get, right? So we'll probably do some lower. Let's do like lower end SKUs. DDR mega transfer. We'll just do mega transfer. We'll just do the number. Well, mega transfer to DDR5 starts at 4800, right? 4800 MT. There's probably like slower stuff like 1866 on DDR4 and something less than 4800, but we're gonna start with these as the ceiling, and then we have 2400 MT. The next one up there is what, 5000, I guess, MT. I don't know. 2666 MT to 5200 MT. That's another one. Then we have 2800 MT, although you never really see anybody using that anymore. Then 2933 MT would be like, let's just go ahead and make this one. Let's try to simplify it, get rid of some of those. 3200 is like 5600. The reason why I'm using mega transfers instead of megahertz is because if you start saying like RAM running at 6 gigahertz, that's not actually what it's running at. So it's like more like half. But anyway, 3600 MT is like 6000, and then you start going up above that. You know, like 38. And so on, and that gets into like 64 or like DDR4 4000, or I forget what the number, what the timing was on there, but it's like somewhere around there is like this or something like that. Whatever, we'll just put that as a blanket statement. So this is kind of the conversion, right? So this one, the F clock 1-to-1 ratio. So this is the one that most people are going to probably want to aim for. Now, what I do at launch, I temper my expectations accordingly. So if AMD is claiming that 6000 megatransfers is the sweet spot, then great. But if that requires a mature platform or winning the Silicon Lottery on launch day for a good IMC, then I'd rather get 5600. More affordable. More affordable will be 5600 mega transfers. So I think that this is probably going to be this with like really good cast latency timings will probably be better value than this, at least at launch. And if you're looking at high capacity, I'll probably say, rather than say more affordable, higher capacity. I think this is what we're going to consider, right? Like if for example, if you want to do 128 GB, right? Like if you want to do 120 gigs, 64 aim for 2x 32. If you're going for 6,000. So if we go back to the browser, where is it? So you go back over here. We look at this chart from G-Skill, right? So DDR5 6000 forecast latency 32, 38, 38, 96. You have the option for either 32 gigs or 64 gigs. Now the question is, how are you going to populate the DIMM slots? Because if anything, if Zen 4 is anything like Zen 3 was, and it is, as far as I know, I don't know how good the IMC on that's going to be, but if it's going to be like Zen 3, then you're going to want to run bigger DIMMs on 2 slots, 2 out of 4. So meaning if you want to do, you want to try to go for 64 gigs day one on 2 DIMMs. So you want to go for the 2x32 capacity. Especially if you're going for the 7950X. So this is the reason why, like, when you start thinking about getting a flagship product like the 7950X, for instance, the top end SKU, you change that, and that changes everything, or that kind of influences the direction of the entire build. Because now you, like, why am I saying that? People are probably like, what am I talking about? Let me go back over here. So if we look at this, wait, why? Okay. If we look at this rule of thumb, right? Adobe AE, they typically recommend, and this is just them recommending for content creators, people who edit video, people who do editing, advertising, like they do the graphics and all that stuff, Photoshop, whatever. The RAM in your computer should be 4 times the CPU cores that you have. So if you have a quad-core i7 from 2013, you know, 4 times 4 equals 16. So that's 16 gigs of memory. If you have a 6-core, like Coffee Lake i7 8700K, which I know there's a bunch of people out there that still have those, or if you have Ryzen 3600 or Ryzen 5 1600, right? Or 2600 or 2600X or whatever it is. 6 times 4. Now that's going to be a weird number because it's going to be 24 gigs. So you're typically going to be on 16 or 32, somewhere there, right? So probably round up 32 or you round down to 16. That's why I don't like 6-core CPUs. They just make this kind of wonky. Now, ideally, more is better, typically, when it comes to computing resources. So, 6-core, I'd probably go with 32 gigs. By today's standards, I would probably be on 32, regardless of what computer I'm using. You know, like, but if we're going with a 16-core CPU, you want to be on 64 gigs of RAM, minimum. So that, or I wouldn't say minimum. That's the recommend. That's where it should be. Minimum would be like 32. So that shows that it's underutilized, or it's under doesn't have enough RAM for how many cores. And then the VRAM, same thing. VRAM needs equal CPU cores, so you have a 16-core CPU. You should have 16 gigs of RAM. So again, like the RX 6800, 6800 XT, 6900 XT, 6950 XT, they all fit the correct profile. Radeon 7, it's a little bit older, but it fit the same profile. On the NVIDIA side, nothing really fit that profile. You were either stuck with like shortchanged on 12 gigs, aka RTX 3080 Ti, or the 2080 Ti, you know, or some weird like 11 gigabyte 1080 Ti. So, you know, those type of things is kind of odd. You know, NVIDIA's RAM count has always been kind of weird in my mind how they do it. Doesn't make it easy when building out a system based off of Adobe AE recommended specs. So that's just something to keep in mind. But in terms of memory, like I would suggest if you're going for 6,000 megatransfers RAM on DDR5, that's going to get you something equivalent to 3,600 on the DDR4. So yeah, that gives you that F-clock 1-to-1 ratio, according to AMD. You know, but you don't have to do that because I think like if you're going to run 128 gigs, if you're going to fully balls to the walls, load it up day one, all 4 DIMMs, because it looks awesome when all 4 DIMMs are populated with the RGB RAM. You know, get that Trident Z in there, Z5, that RGB, and go all out. You're probably going to be running on 5600. So if it was me, I'm probably going to be buying this. I'm probably going to aim for this. Not 128, but I'm probably going to aim for 64 gigs, two 32 gig DIMMs day one at 5600 mega transfers. Probably going for that. Probably going to be more stable. It'll probably allow me to overclock the CPU itself and not worry about the RAM. Just leave the RAM as is. Because typically if you overclock CPU, you can't overclock the RAM. If you overclock the RAM, then you can't overclock the CPU. But honestly, overclocking Ryzen is much easier to overclock memory and less so the CPU itself, because oftentimes the auto XFR and PBO and all that stuff and performance optimizer, all those things are actually better at auto overclocking the CPU than manually tuning it. So yeah, if you really want to do overclocking, the best thing to do is look for QVL Expo certified 6,000 or 6,400 megatransfers RAM, and that's probably going to be best in slot for performance. So the bottom one there. But I'm probably going to go with 5600 myself. Let's see what's available actually, since we're talking about RAM. So if we go back to G-Skill's chart here, so I would recommend, you know, either the 5600 at 28. So 5600 divided by 28, do that and calculate real quick. That gets you 200 as the ratio result, which is basically like 3200 by 16. So this top one here on this 5600, this would be like 3200 CL16 on DDR4. So let's see if we can find that. So CL28. It doesn't need RGB. There we go. They call them Ripjaws S5. But I kid you not, this... Okay, the only thing... Wait, 28, 34, 34, 89... 28, 34, there it is. The only concerning thing is they're running the RAM at 1.35 volts. I don't know how safe that is, because DDR5 is supposed to be 1.25 volts. So they need better binning. And this to me shows that RAM, DDR5 RAM is not mature at all. It's still early days because you're running high voltage. This is considered high voltage, overclock voltage. This is overvolted memory to get those timings, so I don't really like that. I would be more interested in, well, that's 64 gigs, and that's $500. $500 for 2 DIMMs. That's crazy. What is this? This is 5600. Same timings. It's just RGB. So you're paying for $100 more for LEDs. Yeah. No. I wouldn't do that. So in fact, this is still too much money. So let's look at what's another one. So let's look at DDR6000. 6,000 divided by 32 is 187. So that's quite not as good latency as that 28. But let's see if that's kind of like well, I don't know what that's like. Is that like 2933 divided by 16? It's a little bit better than 2933 CL16. So what if we do 6000 by 30, but that's 40? So, okay, let's look at this DDR6000. So, get rid of this. DDR6000. Alright, so there's a I want 64 gigs. I don't know why it's showing me this. But what does this say? This is wait, what? This one is 519. 32 38 38 96. That's this one up here. So that would be like the top end if we're talking Flare X. So 32 6000 by 32. That is a little bit better than 2933 CL16 on DDR4. It's a little bit better, but that's not as good as 3200 16 if we're talking DDR4. And they're going for some insane 1.4 overvolt. I don't know about that. That doesn't seem very good. I don't know. That's... This to me is very discouraging. This is the sort of stuff that... This is going to prevent people from adopting AM5. I can already tell. Like, yes, it's cheaper than it was when Alder Lake launched, but it is still bad. Like, it's still really bad. You have, like, overvolted memory, way over spec. In fact, it's overvolted for, like, DDR4 specs. So let's do a paint real quick. Let's, like, talk about this a little bit in detail. So, like, okay, for the voltage, DDR4 voltage was 1.2 to 1.35. Okay? DDR5 voltage is 1.1 to 1.25. These are the JEDT specs. So, where does that leave Expo and XMP? Well, obviously, all the stuff that exists today is, if it's showing some kind of weird overvolt number, first of all, that voids warranties. Just FYI, right? Like, running your RAM at 1.4 volts 24/7, that's gonna void your warranty, right? Like, so that's out of spec. So it's funny how they're just straight up selling this stuff out of spec. That's ridiculous. Well, I mean, this just shows that the technology is not mature yet. So I wouldn't buy this. No, not for stability. If I was just gonna, like, mess around with it for, like, some kind of overclocking machine, not really something serious like 24/7, like if I was not building for production and stability and uptime, this would be okay. But for a workstation, or like for a HEDT equivalent using mainstream consumer chipsets like aka X670e, which is what we're talking about on this stream, you know, I would not buy this memory. Like, and not because it has RGB. Like, that's not the reason. The reason is because it's overvolted to get the spec. So, no, this is out. And that's ridiculously expensive. What is this one? Is this the same thing? This is 30, 40, 40, 96. 30, 40, 40, 96. So this one's, like... Okay, this one has the higher capacity DIMM, but it's, like... It's still overvolted. So it's like, what am I going to do with this? Like, no. So, that doesn't look good. That really doesn't look good. What's this? Okay, this is Ripjaw. This is basically Flare X. I mean, literally all G-Skill's gonna do is validate that it works. It recognizes Expo. They're gonna program Expo profiles on it, and then they're gonna, like, put a badge in that says Flare X5 instead of Ripjaw's S5. Like, that's literally all they're gonna do. So 32. Man, 1.4. 1.4 for 32, 38, 38, 96. So is all the DDR6000 currently 1.4 volts? Man, that's... That's a little concerning. I mean, I would be okay with 1.35, even though it's an overvolt for DDR5 spec. It's at least it's an actual voltage that DDR4 used to run on. So I'd be okay with that. But 1.4 on DDR5 is just, I don't know. It just doesn't seem good for 24/7. There's no like fan on the RAM or anything. Nah, I don't know about that. That's not gonna last very long. You'll start having like memory errors in like 3 years in or something. So no. I want to say I'm probably gonna have to go with DDR5600 because I'm going high density. Like that's the other thing too. The more dense, if you're gonna do 128 gigs, like 6,000 might not even be feasible. So that's why I feel like if you're going 64 gigs on 2 DIMMs, 32 gig DIMMs, you're probably gonna want like 5600 with the best latency. So let's see, cast latency 28. So see, like this is still, oh, this is so expensive. But here we go, Flare. Okay, this is basically Flare X. 28, 34, 34, 89, 1.35 volts. So that's better. But that's still like, this is basically the highest tier on the DDR5600. So it looks like you got that as Flare X5. We're seeing that right now on the Ripjaw model. So that's basically what this is. So this, I'd be okay with this, but it is so expensive. $500 for 64 gigs of RAM. Oof. That hurts. That hurts. It isn't even ECC. So it's like, whatever. Yeah, there are very slim pickings. Let's look at cast latency 30. I mean, if we do the math, right, the easiest way to figure out what it is take the mega transfers and divide it by the CL number. So if we're doing 5600 and I'm doing 30, so like that number is roughly 186, right? So let's go back to my chart. Let's just make that chart for people that are tuning in, just so they know what I'm talking about. So if we do the ratio, right, like I guess I'll probably have to make a new thing on here. This is getting kind of full of info, but I'll just put it over here. So, like, let's say DDR. Let's go with green. DDR4 versus DDR5, or I guess DDR4 to DDR5. Equivalent. So okay, this is how we do it, right? Like 32. Let's just do 3200. CL16 is what? That's 32. That's gonna be your 200, right? That's gonna be 200, which is what on DDR5? DDR5. What's gonna get you 200, right? 6,000 CL30. Right? How am I? Where is this number coming from? Does anyone know? I think people can figure it out. This is the math part. Math part. 3,200 divided by 16 equals 200. 6,000. Why am I typing like that? 6,000 divided by 30 equals 200. So these are roughly equivalent performance-wise. If we're trying to map DDR4, or if you're trying to buy DDR5 and you want to know like where you match up roughly, this is not a one-to-one equivalent, guys, but I'm trying to get you a good estimate of what to expect if you're buying DDR5. So you need to know what you're getting and what it's equivalent to DDR4. Because this is why people are complaining why DDR5 is so expensive, because let's look at what we're doing here. What's the one that I'm doing? 5600. What was that cast latency? Divided by, let's just do 30 again. Divided by 30 equals 186. Repeated. So what is the DDR 2933 that Threadripper will run at like 128 gigs? It was the cast latency 16, right? So this is DDR5. This is DDR4. And let's do another DDR4. We're probably going to have to expand this because this is not enough space. DDR4 2933. This was a popular one for Threadripper. People who were running maximum 8 DIMMs on Threadripper, like a 2950X back in 2019. Cast latency 16. This is roughly 183. So you can see that this RAM is a little bit better than this. So it's kind of like saying 3000. No, it's more like 3000 CL16. So if we did like DDR4 3000, which was an actual spec from like Corsair Vengeance, for example, that gives you roughly the same amount, roughly the same, right? So this is kind of a good way to figure out like what is the kind of RAM that you need to get. So for example, the popular 3600 CL, let's just delete this, I guess. Well, I'll leave it there because people are probably gonna want to reference that. So let's do DDR4 3600 divided by 16. This is the one that gave you the 1-to-1 on F clock, 225. So that's very high performing. What's the? I probably need to delete some of this other stuff that's up here. But DDR5 6000, right? Like, oh no, is it? Yeah. So 6000 is supposed to be 1-to-1 F clock. I've put it right here. I've put it over on the right side. You guys can see it right there. But essentially, this is kind of what you want to look at. Like, if you want to go higher, then did I delete some? Well, whatever. Oh wait, no. What happened here? Oh, the DDR. We don't even need this stuff. Just delete this, I guess. Like if you want to go higher, DDR5 64 by, I don't know what the cast latency is, but like people are probably gonna say like, what if I just get DDR4 6400? The reason why I wouldn't buy just DDR4 6400 is because that's typically gonna be cast latency 40, and that's gonna be 160, right? So that means your ratio is really, really bad. So it's actually not as good. So I would go for a high ratio. I always buy RAM with a good ratio, like close to 200 is what I aim for. Like, this is the reason why this RAM was so ideal, because it's over 200 on the ratio, and it was 1-to-1 ratio on F clock. It was 1-to-1 ratio on F clock for Ryzen, for Zen 3. That is the reason why that was the RAM that everybody looked for. So if you're wanting to do the same thing and you're buying, or if you're tuning in for the first time and you're on an older system like Skylake, you know, first gen Ryzen, or Zen 2, or God forbid, Pile Driver, or Bulldozer, or Sandy Bridge, or Nehalem, or the Q6600, or some super old Athlon 64, for whatever reason, and you're just now trying to get caught up with what's coming out, and you don't want to upgrade for another like 5+ years, you're probably going to want to aim for DDR5 6000 megahertz or mega transfers. So the one that I've circled, that will give you the F clock ratio 1-to-1. Now, the caveat of saying that, having said that, aim for 64 gigs on 2 DIMMs, and that's pretty much, you're going to be set. Now, what I'm guessing, what I expect to happen is the official spec is probably going to be 5600. I'm guessing this RAM is going to be more ideal at launch because it's probably going to be cheaper. So it's more affordable, and I strongly believe that if you want to populate all 4 DIMMs and go to full 128 gigs, you're probably going to be on 5600. I don't know if you can populate all 4 DIMMs for Ryzen 7000 and run them at 6000 mega transfers. I mean, I could be wrong. It could be the IMC is awesome and it can handle it. It could also be, you know, the teething problems that we saw with Ryzen first gen could sort of semi-repeat themselves again. So I'm just trying to set expectations, right? I'm tempering my own expectations, thinking that, you know, if it has IMC limitations, if its motherboard BIOSes need to be tweaked, and if you want stability and you want high capacity at launch, I think you'd be better off with 5600 megatransfers RAM. That's basically like running 3200 DDR4, right? It's like it's a little bit worse, but you know, you're probably going to be able to run 128 gigs. I don't know what the official spec is. I haven't looked it up in terms of what Ryzen officially supports. But my guess is it's going to say 5600 is like stock Expo supported profiles, and they may have some Expo profiles for 6000, but I don't think those are going to be running at high capacity. Like, you probably will be able to run dual rank 32 gig DIMMs, but I think if you try to run 4 of them, you might run into problems running at, like 6000 or higher, or like 6400. So that's what I think is going to happen. I don't know if that's how it's going to play out, but I wouldn't be surprised. Meaning, if that's how it ends up being, I'm not going to be disappointed, because that's kind of how I expect it to be going in. Adopting a new platform as an early adopter from scratch, I kind of think that's how it's going to be. Typically, what I will probably end up doing is buy 5600 to 32 gig DIMMs for 64 gigs day one, and I'll probably upgrade to 128 later. Or alternatively, what I could end up doing, keep the platform, and then, later on when, the Zen 5 or Zen 4 Plus or something, maybe Zen 5 comes out and has a better IMC, then I would upgrade to like, 6000 mega transfers or something like that. That's the way I see it. So you could keep the same motherboard, right? Because the socket's going to be backwards compatible, but the RAM might change, and it's also going to get cheaper over time too. So that's why I'm probably going to aim for 5600 day one. If I can find 6000, great, but I don't think it's going to be affordable. In fact, looking online, so looking at this, so I found this. So the G-Skill Ripjaws S5, this is 5600 3066 or 3689. So if we come over here, 3639, so that's that middle one here for the Flare X5. So it's basically that same exact SKU. So this is 439. I think this went out of stock, but I think I was tracking this one a month ago. And the thing I like about it is it's 1.25 volts. So that's the other thing too. This is actual spec, like this is proper voltage for DDR5 specification, because like it's supposed to be 1.1 to 1.25 volts. Anything above 1.25 volts is considered an overvolt on the memory. So I like that this is not overvolted. So I would be okay buying this. Yes, $400+ is a lot for 64 gigs, but it's roughly 100% more money than DDR4 for this particular one. But this is not as bad as what we were looking at earlier. It's not overvolted. I know that's going to run out of the box on this profile, regardless of whether it's Expo certified or not, just because it's 5600 and it's 1.25 volts, so there's not a whole lot you can say bad against that. So yeah, this one looks pretty solid, so I'm not surprised it's sold out. But they do have this one also in white, so, and it's $10 cheaper, so it's the same, same timings. So this would be good. I don't care about RGB, so this is a sort of, and it's low profile, so it'll fit next to my Noctua NHD 15 without any problems. So, or it could also fit under like a Threadripper cooler too. So, yeah, this is good. It's expensive, but that's kind of just the world we live in today. So, I'd go with this. So, I don't know who else stuck around. I know that was pretty long discussion on Ryzen. We talked about the AM5 socket. We talked about what is the actual chipset, the fact that it's actually two B650 chipsets teamed together. So you have a primary and a secondary, and those two B650s together is what essentially is X670. We talked about the PCIe lane allocation. So you have 28 total, 4 go to the CPU. There's a really, really good article on Tech Power Up. I will put these articles, these links in the description after the video. After the stream is over, I will add all this info for those who want to look it up. But this is probably the best article online that was published by Tech Power Up back on May 31st. Like, this image right here is worth saving because it gives you the AM5 interface. This is not the chipset. This is the AM5 interface, meaning this tells you what all those pins on that land grid array, on that 1718 LGA socket, what they can actually connect to. So you've got pinouts for your PCI GPU slot. You've got general purpose for the M.2 PCI Gen 5 SSD. You have another set of 4, which could go to either another M.2 Gen 5 SSD, or it could go to a Thunderbolt controller for Thunderbolt 4, or it could be to an ASMedia USB 4 controller if you wanted if the motherboard designer or manufacturer opted for that feature. And then the remaining 4 go to the chipset, and that kind of splits out because, you know, one PCI 5 lane is equivalent to 2 PCI Gen 4 lanes, so you have a lot of PCI 4 connectivity that way. And then you have your USB, then you have DisplayPort outs. Whether they're going to integrate them or not depends on the motherboard. So again, the models really matter. And then you have your USB 3.2 Gen 2, these ones in blue, wired directly to the CPU. So that's really nice. You have very fast connectivity. These blue ports are ideal for things like, you know, external USB capture cards, VR headsets, you know, things that use a lot of bandwidth over USB. That's what these are going to be good for. So really good article overall. Like the chipset connectivity, I didn't even talk about this, but basically the B650 chipset layout, this is what you get with the B650. And remember, the X670 is basically 2 of these together. So this is where you're going to see like the USB, the 20 gig USB, the 10 gig USB, the ones that go to the front header, the ones that go to the back of the motherboard I/O. The USB 2 is probably going to be front header. They're probably going to front load a lot of these USB 2s. But, you know, sometimes Gigabyte puts a lot of them on the back. They're like one of the only ones that does that, though. I think MSI and Asus and Asrock all kind of push them all to the front, and they give you like all the ones that go to the CPU on the back. And I think they might reserve one for the front. But typically, your 20 gig USB 3.2s are going to be on the chipset. So you can kind of see how that's all laid out here. So this is a really good article, probably the best one that I've found, talking about Promontory 21. Promontory 21 is the code name of the actual chipset. I mean, they never changed the name. Promontory was always the name of the chipset. That was what the X370's code name was back in the day. So, yeah, I think that's pretty much all I wanted to say compared to Alder Lake. So here's the Alder Lake one. Yeah, it's comparable. Alder Lake doesn't have... So, Alder Lake's chipset doesn't have Gen 5 for the M.2, but you could run like an add-in card into the second PCIe slot and bifurcate that for by 4x4, you know, and get M.2 PCI Gen 5 that way. So it does have some kind of forward compatibility there. So I'm not trying to sell Alder Lake short, but they don't. It's not as advanced as what you're getting here, and that's just because it's older. Now I fully expect the Raptor Lake X or Z790 to potentially add that. I don't know what they'll change. Typically, you know, with Intel's annual updates to chipsets, they'll improve stuff like they might add, you know, an M.2 Gen 5 or something, or make the DMI 4.0 be equivalent to PCI Gen 5. It's kind of strange how they do it. They have their own proprietary setup there with the DMI link between the CPU and the chipset. But essentially, it's it's all about like throughput and burst and throughput or burst speed versus throughput speed and that sort of thing. But I think we're living in some really interesting times. If you're like a technology enthusiast like myself and you're really interested in adopting the new technology and toying around with it and seeing what you can do, essentially the way I see it, X670e and to a lesser extent Intel Z690 on the Alder Lake stuff, those are trying to overlap somewhat into the HEDT territory, but I feel like the only reason why they're able to achieve that is because of PCIe Gen 5. I feel like they're really, especially AMD, at least right now, from what we know, is really capitalizing on PCIe Gen 5. They're going all in on Gen 5 to be able to give you a lot of connectivity that you typically would have to only get using an HEDT solution like Threadripper or, you know, like X299, Skylake X back in the day. But unfortunately, those platforms are gone, and really Threadripper only exists in the workstation market today, which is, it's kind of sad, but it is what it is, right? So, and I think the average user, the only time I think you're going to be limited on PCIe lanes on this platform is if you're trying to run a lot of M.2, or if you're trying to do a lot of like high-speed storage or RAID 0, and you need a lot of like bifurcation on the PCIe slot. You need like an X16, so you can do 4x4x4x4. You know, if you want that, then, you know, you can do that on this platform, but you'll have to do weird things. Like you'll have to run the add-in card, whether it's like a super micro or something, in the top slot. You have to put your GPU in the second slot, and the GPU is going to run. Well, no, even then it won't work. I don't think it'll work because you're only going to end up with by 8 lanes in the top when you do that. So I don't know. It's kind of weird. Like, yeah, I guess the best thing is like by 4x4 Gen 5, or use an add-in card, or hope that or choose a motherboard where they give you you know, another M.2 Gen 5 instead of like a Thunderbolt controller or a USB 4. So it really depends on the use case. And that's the only bad thing about mainstream desktop. And that's why I feel like the fact that we're having to go through all these different exercises to figure out like which motherboard for what use case and all this stuff. Typically, if someone was a power user, they would just ignore all of this and just go HEDT. Like they would literally just go Threadripper, you know, or, you know, Intel's now dead Skylake X. That's what they would do, because you get so many PCIe lanes that you don't have to worry about this kind of stuff. Like you could run your bifurcated 4x4x4x4 M.2 expansion card in the PCIe slot, and you'd have a bunch of like X16 wired lanes. So anyway, guys, that's going to be it. I don't see any questions in the chat. We did have comments from Mateo early on. I don't know if you're still out there, Mateo, but I haven't seen any comments come in, so I feel like I either put everybody to sleep earlier on, they just like left the stream or left the chat. But it was a lot of info. We covered a lot of info. So I will probably do another video on deep dive on particular motherboards, maybe once we get more info. But I'll probably do a live stream for building out the new Ryzen 7000 series desktop. So I'm going to try to get the Ace. This is the motherboard. Based off of all my analysis, I think this is the one to get. If you're aiming for a top tier flagship motherboard, I think MSI's actually got the best one right now. I also think this one's going to be more affordable than the Asus Crosshair. I think this is going to be cheaper than the Hero. Not by much, but it probably will be. If I had to guess the price, this might be $499. So this might be a $500 motherboard. It's a bummer. I wish it was like $450. I hope it's $450. But I'm pretty sure it's going to be over $400. It is what it is, right? Like they're selling you like gimmicky. Like the coolest thing about this board is they added a new button. They call it the smart button. You can program this in the BIOS to do something like turn on or off the RGB, turn all the fans to max speed, so you can basically toggle through your fan profiles. You know, it's user programmable, so that's really cool. You got the 10 gig NIC, you got the Wi-Fi 6E. It's actually the AMD Wi-Fi 6E, which I'm interested to try out. I won't really use it, but I want to test it out at least. So it's better to have it than to not have it. You know, and then your display port, alt mode on this one USB-C port here. You know, the 8 ports, I would have liked to have 11 ports or 9 ports on the back for USB-A, but it's okay. Like, I don't use my Elgato USB capture card anymore, so I would only ever max all 8 of them out at most, and then I could, you know, move something to the front if I had to. But this would work for me, so I'd probably go with this. It has that expander card. It has basically everything that I would possibly use without having to buy like add-ins. It has a really good detachable heatsink thing for the Gen 5 drive. It has Dr. Debug, you know, like that's not missing. So, and at least MSI respects the PCIe slot spacing. Like this, the second and third slot actually have proper spacing, unlike Gigabyte on the Z690, who decided to put everything like right next to each other. So as soon as you plug in a double slot add-in card on the top, then you can't use your bottom one. So yeah, I like how MSI has the proper spacing here. As far as I know, the Noctua NHD15 will fit without any clearance issues with the heatsink, so that's really nice too. I know that the Strix Z690 was not compatible with my cooler, forcing me to go with a non-Asus board last year. So yeah, that'll be interesting. 6 SATA. It looks like you got the 2 USB 3 headers. They're right angled. You got 2 3.2 headers for the front panel. I can see them right there. So it looks like a good motherboard. So this is probably going to be the one that I'm going to get. It's a solid choice. I'm hoping that I will be able to get it on day one. But it supports, the other thing too about it is it actually supports SLI. MSI is probably the only one that still supports NVIDIA's SLI. Not that anyone really uses it anymore, but I remember I saw it. Yeah, right here. Oh no, it supports, okay, never mind, take that back. I thought it did. Maybe they had that mistyped and they updated it recently. I think I checked it a few days ago and it said AMD multi-GPU and NVIDIA SLI, but oh well. Alright, well anyway guys, that's probably going to be it for this stream. I will do more content in the future on potentially more motherboard content or maybe more CPU related stuff. I don't know yet, maybe something on GPU. But expect to see more content from me on this in the future. If you like this content, be sure to subscribe so you get notifications on when I go live and I cover more in-depth discussion related topics like this. And as always, I'll catch you guys in the next one. Thanks for watching.